Hello there, my name is Michael Maynard and welcome back to Gorilla Picking. Now, the safe that you see in front of you there, if I can call it a safe, is a horrible Chinese thing. It is a thing called the Noble Electronic Digital Safe. And let's be honest folks, it is a piece of rubbish. And this is the sort of stuff that you see in hardware shops, you see it in low-end locksmith shops even, you see it. You know, these things get sold pretty much ubiquitously really, and I have chosen to review this one because it is the same as pretty much every single other Chinese safe. They are all almost identical. Now, the story behind this one is very simple. I bought it as a wreck, so the electronics on this do not work. The safe is dead. I bought it for 20 bucks because I want the carcass of this thing for another project, and we're going to mount different locks on it and we're going to do all sorts of cool things. But before I get to that stage, what I thought I'd do is use this safe in its current form to demonstrate how these things actually work and why they are so rubbish. So we're going to go through the electronic mechanism at a later date. I'm actually going to do that in tandem with another little one that I've got of these branded Yale, if you can believe that, which actually does work. And so we'll talk about this one and the Yale one side by side. But I just wanted to go over the physical construction of this thing first. So the first thing that you see here is that it's actually pretty small. That is 350 mils wide, so just over a foot wide. It is made of steel plate that is 6 millimeters thick, so that's 6 mils, and then there's a coat on either side of it. What's the word I'm looking for here? It's the powder coat. So the metal is powder coated front and back, and these things are not particularly solid and not particularly heavy, so I can lift that off the table without too much trouble at all. So they don't really present a great deal of a challenge to a burglar. They are very easy to drill through, and this one they almost all come pre-drilled with holes in the corners, so there's little holes in the bottom here. And this one actually has had a couple of holes drilled in the back as well. I don't know if you can see that if I lift that up, but there's a couple of holes drilled in the very back because the chap that had this before me had this thing mounted on a wall, so he just had a couple of carriage bolts going through into the stud in the wall, and he just drilled through that with a just straight out battery drill, you know. So these things are not impervious to drilling by any means. Now, the other thing that we need to talk about is that they do have a fail-safe system, and this is where, in the case of this safe, it actually gets a little bit interesting. If the electronics die, or if the batteries die, so the batteries are mounted inside this thing, right? Then pretty clearly you have got a problem, and so there must be a second way of getting into every one of these cheap electronic safes. Not so for a decent quality safe, okay? If you have got a Sargent and Greenleaf whatever model lock on there, Titan, doesn't matter, and that fails, you've got big problems. You're going to have to penetrate that safe. But with these cheap nasty ones, they all have a manual override, and the way that the locking system actually works in here is very, very simple. This little knob here wants to retract a bolt. It can't because there is a little pin in the way. Now, in the normal way, what happens is that you input the combination, a little electromagnet activates, pulls the pin out of the way, and at that point this knob can turn. Now, if that system doesn't work, you can manually override it simply by putting a key in there, turning the key. That physically moves the pin out of the road and the safe will open for you. Simple as that. Now let's get down and talk about the lock itself. With most of these safes, and I'll just zoom in, most of these safes have got a tubular lock on them, so by and large they are a 7-pin tubular lock, and you guys will know that these are not super difficult locks to crack. But they are a little bit more different, a little bit more difficult to a standard pin tumbler lock, and they do put up a little bit of a resistance to picking. Now this one, on the other hand, for shame, is simply a wafer lock, and there is the key. You will see that this is actually a little bit of an unusual key. It's an unusual wafer lock, really, in that one side of the key has been ground flat. So I haven't had this thing apart yet, but I actually think it's an 8 wafer lock. We've got 4 wafers that need activating on each side, but the 4 on this side have effectively been neutered, and leaving us just with bitting on one side of the key only. And as I am sure you can imagine, gentlemen, because it is a wafer lock, it is not difficult to get into. So I think we're just going to prove that now. I'm going to stop the video, get myself organised, and we're just going to open this lock. Give me 2 seconds, gents. Okay, folks, well, we are locked up, and all we've got to do here is turn this thing about 45 degrees anti-clockwise. So let's get a little bit of tension on there. I'm using a what do you call that, a Z-bar, and there's not actually a lot of room to move in here, but let's just see if we can rake that side. Now I might, if we don't get an open within a couple of seconds, I might actually try raking the other side as well. I don't know whether those sliders are actually actively doing something. Yeah, they were. That's interesting. Okay, so we are now open. We have got that out of here. So how long did that take? About 10 or 15, well, no, maybe 20 odd seconds. So what we're going to do next, I am going to pull that lock out and we're going to have a look at it, and then that'll be the end of this video. Next video we'll start talking about the electronic guts in here and see what it does. Back in a second. Okay, so here are the internal workings of the safe, such as they are. Incredibly cheap, nasty battery terminals, and I'm actually wondering if that might be the only cause of this thing not working. I just wonder if the battery connections might be crap, so we'll have a look at that in a second. But here is our bolt work, such as it is. It wants to be able to slide, but you can see that there is that pin there that stops it from retracting. So what we need to be able to do is depress that pin to get the thing to move. We can either do that by pulling it down with the electromagnet, or this little cam arrangement here, that's the back of the lock. So now we're going to work on that. Okay folks, well, we have got this truly hideous quality little lock out of there, and what a nasty little piece of work it is. It is a cheap, again, I know I keep on saying, you hear the word cheap and then Chinese all the time, but it is what it is. So what we've got in there is 8 sliders, 4 on each side. When it's in the lock position, those sliders poke out each side of the core. When we poke the key in there, that retracts those sliders, and at that point the core can turn. And if I remove that, you'll see that those sliders, if we just zoom a little here, are sitting pretty much flush with the plug. If we were to withdraw this key, what's going to happen is that those sliders, which are under spring tension, are going to ping, but because there's no core to hold everything in place, they're just going to ping straight out. So I'm not going to withdraw the key, but you know what a slider looks like when it pops out of a barrel. So there you go folks, we have got the truly nasty Noble electronic safe. Unfortunately, it is completely typical of its kind. This is just what these things are like. This is just how they are. But for us, it provides the basis of a bit of an interesting toy, and we're going to get a couple of videos out of it yet. So thanks for watching, gents. Next episode, we'll start fiddling around with the electronics. My name's Michael Maynard, and this is Gorilla Picking. Leave a comment below.